Okay, the other thing I wanted to look at was the fact that Simon Dan here did this image where he did the overlay, and this is not the same two images that I compared. So let me do the same two as him, and I'm going to do it in super fast turbo mode. That is the comparison of this image and this one. So I've already pre-lined it up. There you go. You can compare transparency version, and that's a pretty good lineup. Pretty good lineup, I think, right there. So, and also I did this, drew the lines so that we can see approximately how much of the island we were seeing from 39 miles. So this is from 39 miles we see from the blue line up, and that's basically at the shoreline. And then this is from almost 32 miles at 300 feet of elevation. We see almost all the way down to the waterline, to the very shoreline. So how does that compare to Simon Dan's analysis? You tell me. He's got it showing this much. I got it showing that much. It's close. I mean, I think he needs to pull his mountain down a little bit. As you can see, the overlay is up a little bit, so it needs to come down. But once he does that, looks about right, about the same. So yeah, that's fine. None of this is scientifically precise by any means. Oh, I wanted to take those same points and look at them in Peak Finder. Peak Finder is awesome. Little plug there. It's pretty cool. So here's the one we were just looking at, which is the 39 miles away from the shoreline, and you just see a little nub. And then this one, get rid of that thing. This is the up high. Yeah, this is the up high at almost 32 miles away. So it's much closer than the one we were just looking at, and also raised in elevation. So you can see almost down to the shoreline. You can see where it starts to flare out there. Right there would be where the flat part is. And in this simulation, they are expecting that little beach, I think, is right on the waterline. So it's probably getting cut off. And then here is from the shoreline down close. This is the 30 miles shoreline. So you cannot see that beach at all. The bottom half is cut off. So what does that mean? That last image we were just looking at is this one. And let's compare it. In this image, this is a simulation from Peak Finder. They are not showing the little curve down, the little curve that happened, the shoulder, I call it. This little shoulder doesn't show up on Peak Finder. Peak Finder, therefore, is showing us the horizon would be expected to be about here. And if we go back to this one, Peak Finder shows us very, very similar view, but again, I think the very, very bottom of the island is expected to be cut off, and I think that matches this this estimate right here, which says that the bottom 50 feet is expected to be cut off right there, but I think maybe we're seeing just a little bit extra. So what does that prove? That doesn't really prove anything. What it shows is that we expected to see all but the last 46 feet, and we saw all but the last, I don't know, what are you going to call that? You're going to call that 10 feet, 20 feet? So there's maybe 30 feet extra, 35 feet extra that we're seeing that we didn't expect to see in that calculation. So what that tells us is that this calculation is off by 30 feet. This is just an estimate. read this stuff here and try to understand that this is just an estimate, and it's an estimate because it varies a lot. And that is why taking observations down near the horizon is a terrible way to try to prove that the Earth is flat. So what we do know is when you go out to 39 miles, that is what you see. And then when you come into 30 miles, that is what you see. You see a lot more. As you go farther away, the bottom of the object becomes obscured by the waterline. Now, the obvious explanation for this is that the waterline is curved, that the Earth is curved, and you're seeing the object disappear behind the curve. That's the obvious explanation, and it is borne out by this sample right here. To strengthen that is this sample, which shows that as you go higher in altitude, you can once again see the bottom. Start at the beach, and then you go up 300 feet higher, you can once again see down to the bottom of the island. And if the Earth were flat, not taking refraction into account, if the Earth were flat, that would not happen. If there is some refraction effect, then who knows? We're going to have to get really deep to try and answer why you're seeing what you're seeing if we have to involve refraction. And clearly there is some refraction going on here. So that is why you really don't want to try and prove the Earth being flat by looking at the horizon.